Morning, everyone. We should start soon. Uh, okay, you can just react on Slack if you're ready for today's session. Mm, We shall wait for more. Okay, yes. Okay, good morning, Wosumuzi. We shall start soon. That Anna Smith. Okay, we have about less than 60 joined on Slack. Okay, just gonna wait for more people to join, and then we can start. Okay, we shall start at 9:40. 2 more minutes. Okay, I think we can start. The others can just join us as we go. Hey, good morning, everyone. So my name is Violeta Vidi. I was just doing the review of yesterday's session, and then we can continue with our daily plan. So yeah, yesterday, basically, okay, just briefly about myself. I'm working closely with Benjamin as a software developer intern. I'll be assisting with the review for maybe today as well as tomorrow. So that's just a brief of what happened yesterday. So basically, yesterday was about Streamlit, one of the libraries, Python libraries for visualization. You can use it for quite a lot of things to visualize your data, dashboards. You can do prototyping as well, So yeah, that's more about it. So this is something that it's very useful. It's a very good useful library as well. Just to for EDA, as it was mentioned for active visualization as well. So basically this is just a powerful app as well. You can just make your app, share it with others as well, share with your people that we work with or you want to visualize the data with. So yeah, just gonna start with that. So just gonna do basically just follow this. How to get started with Streamlit. Then just gonna do what the basically the app that we did yesterday, which is what you see on your screen now. Then just go through that. After that, we'll just maybe just go through running the app. Which I saw quite a few people yesterday having a bit of a struggle, having a bit of errors as well on the terminal, which is they were looking on the console on Spider, which Spider which we're using as an environment for coding at this point in time. You can use different IDEs as well. You can use your Visual Studio Code or whatever the case may be. So just gonna start with, okay. So what we're gonna start with, as it was said yesterday, for Streamlit, basically to get started, you can just run Streamlit maybe here if you want, but just gonna start with, okay, you can just go on your search bar, then you can search here and search for Anaconda, a prompt, just to get started. You're gonna use that one because I already have it open, so it's fine with me. Just gonna open, you can just press there, just gonna step by step, a little bit quicker. So I have my command prompt open. If you want, you can open command prompt via Anaconda. Uh, some might have it, some might not have it. You can see there in one of the applications that are open there, you have Anaconda prompt there. You can just open it there. It will show as well on your taskbar. That's another way of opening the command there, the terminal. Okay, so basically how you install Streamlit as a library, you can just say pip install, then you can just mention Streamlit. So just do that, then you can just press enter. That's about it. You have Streamlit installed on your Conda environment. Okay, but the thing is now my environment is not activated. Let's just do this. Not Conda prompt. Let's use this one. Here we go. Okay, here we go. You see there is base in there, which means I'm in my Conda environment. I just use pip as I've done it before. So what I usually do some other times just to check if Streamlit is installed, I just check the version of, which sometimes does work. Sometimes when I'm having issues, I can just check the version of Streamlit that's running on my PC, on my environment. So you can see the version, meaning that I already have Streamlit installed, so I don't have to install it again. So just for testing as well, what we did yesterday, just to test Streamlit, you can with hello, that, uh, just wait for the browser to open, and you will see your browser, you will have that. So meaning that everything is good as well. You see, we're not going to go through every detail that Benjamin already went through yesterday, the animations, the mapping demo, all that. We already went to that. Maybe if you have any further questions or you want more explanation on that, you can just have a conversation on Slack. I'm always available. William Feedy. Okay, so yeah, that's about that. If you want to stop it, you can just stop it by Control C. So yeah, you can just install that if you want. PIP install PyDeck if you want. You could install that module. Because I'm opening something that basically needs that module. Okay, just close this. I'm not gonna go take much time on this. Okay, so now another way of that's one way. I'm just gonna come back on when you want to run your project on the terminal as well, maybe a little bit later after this one. So now we're just gonna start running Streamlit on Spider. Basically, Streamlit will not run on your console because this is just a Python web application. It's running on the web, basically. So what you can do, for example, if you see here, basically what I said yesterday, you have to download those files. Probably most of you have already have those files downloaded and then you have it on your folder. You can see that. Here's my folder here. You can just see your files. I have all the files that I need. Let's see that. Okay, go. So now what you're gonna do now is just gonna start running the application. Another thing that I noticed that a lot of people wanted to do this just to test. You have all the rights to do what you want. Uh, break the code as much as you want, test whatever that you think you're not sure of. Will it work? Will it not work? You have all the rights to do so. If you comment all these files, you can just notice something here. Let's do this. You can see you have an error there, which means undefined name, because when I use file, there, which is file, we need to be assigned to something. So we'll have that error. So we need to have something here. Okay, sorry about that. Okay, so now what you're gonna do now is quite another thing that I noticed yesterday. Just do this before I start exploring this. That as well. We can test that as well. What will happen if you just uncomment all those lines of code? You can just test on your side which one will show on your web application and all that. Once you open it, you can test that as well. But as far as I know, the last one will be assigned, and that's what will show. We're using subprocess here. We have to import subprocess on this file. Basically, subprocess, what it does, it allows you to run commands, shell commands, basically on Streamlit. Because if you see here, I have a comment that I've made. So basically, what happens is Streamlit. That's the terminal command. Streamlit run file, which is file meaning that it's whatever that has been assigned here at the top of your file here. So whatever that is assigned here, you open here, will be basically what will be run by Streamlit. Okay, so I'm just gonna comment this off again. So now running the application now, running the file. So another thing that I noticed yesterday is just to briefly about that as well, is quite a lot of people were running, let's say, in my files. I'll open which one now, app. So I have two. I have an app. I'm not sure if my screen is. Okay. So if you see, I have two files open. I have run Streamlit, I have app as well. Quite a lot of people will run this file. And now let's try and do that. Run this file. Now, do you see what you receive on your terminal, on your console as well? This doesn't mean your code is not working, but it's because you're running this file, and this file doesn't have like an entry point, for example, for your Python web application. So you just need to run wherever your terminal command is, basically. So if you run here, See, just gonna run this file. You see, you're not receiving anything here. It's gonna open in the browser. Then receiving, it's opening on the browser. So now here we go. So now we have the application running. Okay, so now we're just gonna make some changes on my code. Let's try and see if we can do this. Okay, you're just gonna make up some few changes if you want on your code. So this is not where you wanna make the changes because you're running this app UI. You're right. So just gonna go to app UI. Let's say you want to change the title heading, or you want to change this name and to something like coding summer school. So you use write to basically all the text that you want, basically most of the text that you want to write on your web application. Let's say coding summer school. Okay. Typing fast. Okay. Then you save that. When you see on your application now, it's gonna say rerun or always rerun. Better go with always rerun, as it was mentioned yesterday. Okay, that works. Okay, now you see my code in summer school is missing a U there. You can just go in your code and just do that, save. Instantly it shows on the web application. So that's one of it, meaning that Streamlit now is running whatever. I'm not sure if you can see on the variable X. Okay, on the variable Explorer as well, you can see what is being assigned on file, of which is what is going to be read basically by Streamlit. You see. So if you comment this and uncomment the other one, so in most all the apps that you run on the Python files, basically this is what's going to be assigned on the file. This is what file is gonna have, and that's what's gonna be run on your application. So you run here, but it's gonna appear on the browser, basically. Okay, that's quite much easier. You have your widget there that you can play around with if you want. See, just go on your app, you can just change the numbers if you want, make it to 10 or something. And make it to 10, to 100, whatever the case may be, change it. You can see the widget changes there depending on your case, what you want the widget to do. So that's one thing you can do. So you can do it quite a lot. For an example, I can just show you another thing that you can do. Let's say you want this slider to be, we haven't been there before, but I'll just go quickly. Let's say you want to have this slider on your sidebar, for example. What can you do? You see. So the other thing you can do, instead of writing this, because this is showing on this page here, you can just type in slider within there. For example, it says sidebar in there. Just going to say, let's say, and sidebar there as well. I'm also going to be showing you this. Let me save. See what happened. Now you have a sidebar that's running. See now all that just by changing only those two. You see. Okay, go back. Let's just okay. So we move to the other application that we have, which is app plots. You know, if you want to visualize your plots or whatever the case may be, we can just uncomment this one. You see, even if you don't comment it, this one will show if I uncomment it anyway. You see, but preferable, I think one of the experienced researchers was here yesterday to basically speak about the importance of having a clean code and making sure that your code can be reusable. So commenting off and making sure that you're doing the right thing, basically. So yeah, now just going to open this. We can just close AppUI for now, just like that. Then you can just open this one. Same thing, you have your title. Everyone knows what the title is, right? Header at this point. And then you can just have your data frame if you want there. So you can have your data frame x-axis and y-axis there, 1, 2, 3, 10, 23. So in such cases, if you want, okay, let's run this one. So again, if you run Because if you run here, bottom left of your screen, if you hover on top of that play icon, you will see bottom right of your screen, there will be a run file note there, meaning that this is the file that you're running. That's why you will get that warning on the bottom right screen of you. Okay. How about that? Okay, just zoom in. So if you hover that, you can see on the bottom right screen corner, there's a run file, meaning that this is the current file that I'm running at this moment. So I don't want that, of course. This is my main entry point for this application, for this project, actually, and easiest way. So again, we run this one. It's gonna tell us there, it's running, issue. Okay, so that, okay, we go. So again, we have our visualization of the plot. That's our line chart there. You can see with the y-axis that we mentioned there and the x-axis as well. So yeah, that's about it for all the other apps as well. The files, you can just do the same thing on the run streamlit main entry file. You can just make the changes, uncomment, comment until you see all the other files. I'm not sure if you guys want me to go through this. Basically, this is your plot leaf, as it's specified there with a PX. We've mentioned PX there as a plotly express as an alias there. So use that alias to identify what you want on that module, basically. Then x-axis, I had another person asking me yesterday, what is it about again? I think it was about how can we make and how can we open. It's okay. No, I will go. We'll come through that. It's still one of the files. Okay, so yeah, that's about it as well. You can see a plot. You can make the changes if you want. You can change the number 10, 20, 30, and change these y-axis as well, just to explore and crash and mess up your code if you want. Okay. Sure if there are any comments so far. Okay. Okay, just to go again, I see there is a question on Slack. Quickly gonna go through that, asking about what does shell true do. Okay, run streamlit, basically this. So here, this shell is equal to true according to what I know is it's basically telling you to use your system's terminal or your shell terminal, basically. Even if you say false at this current moment, it will work, because you're using Spider and Anaconda, it will still work, Even if you remove this, it will still work. So sometimes preferably they say use false. You can just find out for yourself why it's false, but they sometimes say use false. But yeah, that's as far as I know. I think it has been mentioned as well there. Yeah. Okay, moving on. Now we're going to open the app profiler now. App profiler PY. Okay, I'm gonna comment this one. Open that. So these are basically all your files. Run it to search. Now we're running that. There we go. Now it's showing. So as the more you change on your app, on your code, it's eventually that's what's going to happen on the web application as well. App profiler. This is basically what you can do for yourself, as well as mentioned. This is basically your profile as a researcher. You can just twiddle a bit, put in your name, your field of research, institution. So another one here, you can just browse the files if you want for your publications, basically. Then you show the trends and can explore the data, just go through a bit. We just go in a code a bit for that. Then we have that as well, the widgets and everything. It changes instantly. You have the widgets there. You see. Okay. So on your code, basically what you have will be, okay, a profiler. So you see that how long is that code? So I'm not gonna go through all of that. At this point in time, I don't need numpys. It's fine. So you can just do the changes there for Dr. Jane. If you want, field of studies, research, institution, and all the changes there. You'll see. You can do the changes and for the image as well. So basically, this here is the part with your image. You see. So that one is just one of the online images that we decided to go with. You know, and if you click on that path, it will take you to some kind of other pictures as well that you can use if you want, and then you can just put in your caption. So st.image, basically, as we know that st is a alias. Here, I don't know why it goes to this. Okay, st is an alias, whatever that you need to use on Streamlit, you have to reference it, st dot, then you can just proceed with your modules and whatever the functions you want to use. So that's about that. So again, to have that functionality of uploading, basically you will use this file. If you see this, or this, sorry, upload file, st file uploader. File uploader, meaning that you want that you want the user to browse into their Windows Explorer, whatever the case may be, and pick the file that they want to use with the publications. That is more like a label that tells you what to do. You need to upload. Sometimes it's good to have that so that another person can just know what to do with that as well. So that's basically, then once it's uploaded, you can do all the statistics or all the visualization you want to do with that file, on that file. You need to write on that file and its own publications. Again, data frame, you assign it to that, then you can just use whatever, you can just filter. The code is all there. I'll check again on Slack if there are questions. So all that information that you want to visualize there, from there up to say here is basically coming from your CSV file, right? So the trends, you can see the trends if you want. You can filter by keyword and all that. Okay, just to move again. So yeah, I'm not gonna go through the whole code. I think we went through this yesterday. But if you have any questions, you can just select them. We'll respond to that. So yeah, that's about it. Then you can have gain. Oh yeah, a data set with all the options that you want. That's for the temperatures, the humidity, and all that. Then you can do your if statement. Basically, if we choose physics experiment, if we choose astronomy observation, what must happen then? That's more like coding logic, basically what must happen after you've selected that. And you can have your footer if you want and make it your contact section where you put in your details, right? We all know what right does. So yeah, then we visualize that. Then we go on a profiler menu. Basically what it does, this one, it just simplifies what we did with a profiler, just to have menu items as well, you know, simplify, not to have everything cluttered on one page. You can just have multiple pages if you want, with showing all the information that you want. Okay, just gonna, again, you run the file. You can see now it's only showing only that page which has okay, this one, the profile menu. Okay, so now it's only we have now a sidebar now that has all the items that we want. We have set it, sorry, we have the title for our sidebar. Then we've used like the radio buttons as well for our sidebar to make a selection of where do we want to go, contact. Okay, it's not clear enough. So again, Benjamin did go through that again yesterday. You can have as many items you want for your assignment as well if you feel like there's more that we need to explore about you and all that. Go back into the code. You can upload as well the publications, all the statistics and visualization for your publications will show there coming from your CSV file, of course. So yeah. Also, this as well has been using conditional statements as well, to say if this writer button, basically researcher profile has been opened, has been clicked, basically, is true. If this is true, then this is what needs to show on the screen, basically on your page. So you have your if statement, elif statement, for your publications, you have your menu. Okay, yeah. Okay, so using menu for our writer buttons as well. All that and your contacts as well. You can add as more as you want. You can just say, and if maybe add your experience, for example. Let's try and see if you can do that. Just quickly. Let's say experience. Sorry. Just gonna be brief here. Just say menu. Let's say experience. I'll show you something. Experience. Yeah. Yeah. Let's tirade. And let's make Vuyo a content creator. I'm not a content creator, but just making a. You can put basically you can put your whatever experience that you want. I'm just showing you how to create another menu item, basically is what. So now the menu, it still will not show because we haven't added in the menu items, but the logic for it when it's open, it's gonna show. It's gonna tell. So if I copy this, for example, just for myself to make it easy for myself. So now I need to go to where I have my items, my sidebar radio buttons, then I can just mention my experience where I wanted to show that. Let's say experience there. Then you can just refresh, save. So okay. So where you have your radio buttons, you can just add experience there. You just have to make sure that whatever that you have here is the exact with what you on your condition you have, basically. If you have experience with other name or word exactly, make sure that it reflects that. So you can just go back to here. Yeah, sorry that. Then we have experience now here. So experience will show who is a content creator. That's one of the things that's at least. So yeah, that's what yesterday I was about. I'm not gonna go much on your visualization. It depends on you what you want to see. They are different. There are other visualization. You can see, you can just go on Streamlit.io. You can just, as I mentioned yesterday, this is your playground. You can write your code. It will be visual on the other side. You can have it blank, write whatever that you want. Again, if you don't have this, for an example, what happens? You can just test that as well if you want. If you don't have that alias, for example, let's do this. Let's Streamlit dot write. What happens? See. Again, ST is an alias, as you have mentioned. You see, this is better for you to use ST. Imagine writing Streamlit all the way when you're busy with your block of code. Again, So that's about it. Streamlit, pandas, PD, data frame, and all the others, you can just do that as well. See, okay. So now I think I'm not sure if I doubt if we haven't received much questions on how to write a file and the issues. I haven't had anyone with the issues on their code and what's happening and all that. So I'm not going to dwell much. So what I'm going to go through now is if you want to run, for example, this application now on your terminal, for example, what do you then do? Okay, we can just use this terminal, this one. So now for here, for example, if you're not running via this icon here on Spider, if you're not using this Spider icon here, you want to run it via the terminal, you just need to change your directory to reflect that. So this is the directory where my code is, code in summer school. Let's do that if you want. Have my code in there, you can just copy that if you want. So change directory. So this is my path. See my path. This is what shows. Then I can just string it here. So what am I running now? I'm running now. You see the code that I'm running there. The command that I'm running here is actually the command that we have on our run Streamlit application here. Right. Let's say now I want to run app.py, for example. Here, app.py. Here we go. Let's see what happens. Now you have py, meaning that you must have your path correct. Then you can run on the terminal if you want. That's the other way of running your Streamlit application or any Python application. You just have to have your path correct. Then you can just run your application. So yeah, that's about it on Streamlit. Again, I'll just go through the quiz and then maybe with the project as well, GitHub. Okay.
After thinking and you sent your um link to people in the world,
Yes.
but then you want to fix something, change something.
Hmm.
Is there a way to like make a website down message so that you don't break the code while other people are viewing?
So you don't want, okay, here's a question coming in here. So basically what you're asking is there any way that you can make sure or you receive a notification when someone are viewing your application? Your,
If it's live and then you give a link to someone, you want to take it down temporarily, put it like a note on, like, like when you open an app, it says sorry, but you just take it down.
yeah, you can do that. You can do that because another thing is when you configuring your application on Streamlit Cloud, it shows and it also ask you which file exactly do you want to open. You had people asking yesterday, say file not found and all the other things. When you select your repo where your code is, you select your repo, and then it asks you for the file, basically. Which file do you want to open? You see, you can create another file, for example, if you want, or create say create a file with that message, for example. You see, and then yeah, that's one way you can do it. I'm sure there's plenty ways that you can do it, but it's possible. You can change your code as how you want. Okay, I'm just not gonna check on chats. Okay, so far no questions. Okay, again. So now just gonna just quickly go through the quiz. I'm just open it now. Okay. Okay. Interesting. So 23. Oh, okay. We've got people getting 100%, 98% as an average. Okay, not bad. Lowest score 71%. You can do better. So basically, one of these questions are coming up from what was happening yesterday throughout the day, throughout the Streamlit session. Again, so first question was asking what is it Streamlit primarily used for? So building interactive web apps for data analysis was the correct answer. 99%, which is good. You know, uh, this is all also in the notes on your canvas under the course, data processing, web scraping, machine learning model, and training. Okay, but what we wanted to building interactive web apps for data analysis. Yes. Number two, how do you install Streamlit? We're supposed to be getting 100% for that. It's not at this point in time. Option 3, 96%, okay. To display text on your page, st.write. All the others won't work. st.text, st.show, st.display, different. Okay, so yeah, this is not bad, at least above 95. What type of interactivity can you add with Streamlit widgets? You can do buttons, sliders, tables, text input, checkboxes, sliders, and radio buttons. Whatever that you can think of, you can have it. What you want to visualize on your app. So all of these are correct, are okay. So that's why select number 1, all mentioned. Okay, which library does Streamlit integrate with for data visualization? Again, Mathlib, Plotly, and Pandas, all of these as well. You can integrate with those basically. Not Pandas only, not Plotly only, not Mathlib only, all of the 3. That's the correct answer. How do you add a heading in Streamlit? Again, st title is basically what is preferable to be used for your headings. It's written as st.title, Streamlit.title. So yeah, that's about it. So yeah, you have that's 97% as well, not bad. Okay, so yeah, that's about it. We have assignment, I think, that is to be submitted on Monday, of which you need to create your profile, upload it on the cloud, make sure that it's on GitHub. You have how to create a GitHub account and Streamlit account in there. I'm not gonna go through that. The instructions are all there. But what we need is basically once you have your link, okay. Let's see what shows in here. Okay. So this is my application. This is not my profile. I have a different profile. So this is what my application, this is the application from the pipeline that we did. This information is coming from Streamlit, by the way. This is coming from the pipeline. All this information is coming from the pipeline that we did on day 2. This data is on SQLite. I'm getting the data from SQLite and see if I can show it here. Okay, so market research, we all did market research. We know where to find that file. So now I have that file in here. Then I can just visualize whatever that I want using the path where that file is. Can connect to that market research basically as SQLite. Basically, I need to import that. It needs to be imported. So basically, this is my application that's running on Streamlit. It's in the same path, in the same directory. So what you do is you copy this on your Slack, there should be a Streamlit channel where you will paste your thingy, your link. Looking at questions on Slack. So that's about it. You can just do that and you can just paste it. So that's not my profile, rather my app. Exploring what I can do with Streamlit and what I can visualize on Streamlit. You can create different charts if you want, bar chart, line charts, and other charts that you want to visualize and have your data be visual on, basically. Okay, I've seen you've received quite a few yesterday. Nice. I found a way to import interactive PDB protein. Okay, nice, fine. Whoever that needs to go through that, you can just go on the chat as well on Streamlit. You can just reply if you want to know more about that from David. You can just reply and have a chat with David. David can show you what decided to do and I'm not gonna go through that because of time. So yeah, that's about it. But if you need assistance with GitHub setup, account for Streamlit IO as well to set up your cloud, I can assist you that with. If you need assistance, you can just chat with me on Slack. For the sake of time, check your questions on Slack. So yeah, that's about it. Basically, this is not much about coding, but more about visualizing the data that you already have from your pipeline, whatever that you need to visualize. So yeah, thank you. I will hand over to Benjamin to take us on today's okay, let's go to Canvas, dashboarding, let's go to course. Okay. So yeah, thank you guys. I'll check on Slack if there's questions and we'll follow up on that. Thank you.
Cool. Thank you, Rio. Hopefully everybody knows a bit more about how to solve some of the issues they had yesterday with Streamlit, but please post questions in the chat. I saw there was a few questions as well in the chat. Question 7 in the quiz, what's the difference between title and markdown? So as you can imagine, title is creating a title or heading. Markdown is for paragraphs and text and things like that. So that's the main difference. If I have a table to insert a plot, can you briefly hint on that? I have a table to insert and plot. Okay, maybe give more description of what you mean here. Don't fully understand it, or somebody can reply. But let's move on. So we are going to continue today with data visualization, but moving on to Jupyter. Jupyter is a very useful IDE. If you're not familiar with it, it is useful. People use it online a lot to do training because it's easy to teach with. However, it has limitations in terms of actually, in terms of the coding processes. It kind of skips, the good practices for coding. And also next week, some of the lecturers will be using Jupyter as well. So we want you to just be familiar with Jupyter. The prep course did go over Jupyter as well. So when you did that, so you should be familiar with opening Jupyter and using it. So this morning, we're going to do a short, EDA, exploring data with Jupyter itself. So if you go down to day 4, we have quite a bit to cover today, this morning at least, which is data visualization with Jupyter. There are 2 files here that I needed to download, open a folder, and open a Jupyter notebook. We're going to be using these two files to work off from. In the afternoon, normally Fupi is going to do a presentation by informatics. So there are some files as well and some documentation we can go through as well. But for time being, so please download these two files and open Jupyter Notebook. And we'll just wait for people to do that first before we continue. All right, so please open up Jupyter. Please open up Jupyter and copy these two files to your Jupyter Notebook. If you want to open Jupyter Lab specifically, go to Anaconda, click on Jupyter Lab, click on Launch, and it should open a browser for you that has Jupyter Lab. If you want to upload files, you can first create a folder. If you want to upload those files, click on this upload button, and you can upload these two files specifically, bike data and notebook template. Again, these two files, you can find it on Canvas. What happened to Canvas now? It's that one. What was Canvas? Which browser do I use? Edge.
That's nice.
Was it not open?
Want to open yours?
No, yours is fine.
Yeah, just open on Edge. Open it on Edge. Yeah,
There it is. Okay. So the two files we need is here, which is streamlit file, which is notebook and bike data. So please download that and copy it to your Jupyter notebook. So while we waiting for people to get that ready, this goes just through some of the data visualization notes we have using Jupyter. So visualization is a key skill. We mostly have focused this week on EDA or extracting data and transforming it. We haven't focused too much on analyzing it, which we'll try to do today. But as we mentioned, the ETL part was extracting and transforming and loading, and the EDA part was analyzing and looking at it and creating plots and trying to find certain sentiments or try to find certain trends that you are, looking for. So again, so core skill for data analysts, scientists, and non-professionals, helps you to interpret data, identify trends and decision making, and it's obviously used in the EDA process. In terms of the goals for EDA, understanding the different types of plots is really useful: line plots, scatter plots, bar plots. In the prep course, I gave a very nice site, data viz, which shows you the type of data you have, what kind of plots you should create. I think just if you let's go data viz, there. Yeah, is it this one? Is this one? Oh, it looks very similar. That change it. Yeah. Data viz with the S maybe. It's on the prep course, so somebody can maybe share it in the chat. But it is a really good website to have a look what type of data you have. Should you use a line plot, a bar plot, or a scatter plot? Because that obviously allows you to identify the relationship between the data and what trends to extract from it. And as it mentions here, it's important to understand what visualizations you need based on your data types. Is it categorical data? Is it continuous? Is it time-based? So the tool we're going to be used today to kind of demo this is Jupyter Lab. We're going to use pandas to do the data manipulation, follow on from what we've done earlier in the week already, and Plotly to plot some data and interact with it to gain some insights. The data overview in terms of data set, it includes hourly bike data from Korea for 2 years. There's a whole bunch of data we'll work through. But if you think about it, imagine you are a data scientist, you're a data engineer, you're a researcher, and the owner from a bike shop comes to you and said, have this data. I want to know when is the best time, when will people use or rent the bikes the most during certain peak times, and you need to give a report to that that owner of the shop, and you analyze the data. They have the data, they don't know how to analyze it, and find trends. So that is your goal. That is your problem that you need to try to solve for them, based on the weather or time of day, time of year. You want to give them a report to tell them when is the best, or when is the time to have the most bikes available to people to rent. When is a quiet time, because obviously you need overhead and staff and whatnot to maintain your business. So it is a problem set, we're gonna work with. Some data cleaning steps, things we have done before. This is more in the prep course where we have to, working with date information is really important, especially when reading it in from a CSV file. We have to make sure what data type is actually being read in. Very crucial to understand what data type it is and if it needs to be converted. So we're going to do some date conversions, some Boolean conversions, and filter the data as well to make it more user-friendly. In terms of line plots, we're going to look at rentals over time. So this is for showing progression over time. So a line plot is most suitable here. We can hopefully aggregate the data and to reduce the noise and visualize seasonality as well. We're going to also look at seasons in this data set and to see if there's any patterns we can or any trends we can gain from it, and tell the bike owner shop, the bike rental shop, during these seasons or these times of the year, you should have more bikes available than other. Scatter plots as well, really important to identify relationships between two variables, like for example, temperature and rental. So we'll go through that. The key insights we want to try to draw from is the line plots reveal seasonal trends. Scatter plots show correlation. And data cleaning and transformations are crucial to effectively visualize the data and remove the noise. So only see the data that we actually want to use. So lastly, practical tips, focus on realistic data sets for meaningful analysis. We're going to use Plotly to explore the data, and we try to find the relationships between the data as well. So I wanted to also open up that file in Jupyter. You can see it. There we go. Let's see if Courtney Brown, can we use VS Code to do the Jupyter exercises today? You can use whatever IDE you want. Is Jupyter Lab similar to Google Colab? Yes, it is similar. So I can use whichever one you want. Courtney, if you are asking, do you want to run Jupyter Lab inside of VS Code? You can do that if you want, or you want to run the code. You want to run the Python code inside of VS Code. So I'm not sure exactly what you want, but today's idea is to practice Jupyter Lab. So understand the environment and how it works. Because next week, some of the staff will be, trainers will be using Jupyter Lab as well. All right, so let's look at some of the data just to get a feel of it before we've even extracted it or and start to use it. Let's have a look that we have a date column, number of rented bikes. We have an hourly column. So this is a bit not too useful for us at the moment. We can probably combine date and hour to give us a date time column. So it's something we could look at. We have temperature, humidity, wind speed, visibility, dew point, a lot of weather parameters. Then we have categorical data. We have season. So over 2 years, we have seasonal data. So this is categorical data. So we can look at different seasons. And then these two last columns lets us know if there's it's a holiday or not. So no holiday. Or it was a holiday. A holiday. Yeah, okay, so some of them say holiday, some of them don't. And then is functioning, is a business functioning or not? So yes or no. So there are changes there, yeah. So this is, as you can hopefully see, that this is data that either has two conditions, and to better filter and control it, it is far easier to change this or to map it rather as a Boolean condition, Boolean being true or false. So because it's either holiday is either no holiday or holiday, we can just map that rather as true or false. And that allows us to easily use pandas functions rather than checking for this condition manually. It's a bit of a extra line of code to check this text, for example, check for no holiday. We can just check for true or false. It's far easier, far better approach. So we will go through that step shortly. That is a data. So let's just see if everybody is ready. Is there is your Jupyter open? And do you have your files? See if everyone is ready. Again, I've given you a template, so you can go ahead on your own. You can try to work this out on your own. I've given you guidelines to work from. So, if we're going too slowly for you, by all means, you can start on your own. Somebody is not ready, so please get ready or ask for help. I'll wait for some more emojis before we continue. All right, so let's continue. So just a brief overview of a Jupyter Notebook. So a Jupyter Notebook itself isn't actually a Python file. You cannot run it as a Python file in your terminal because it allows for storing other types of, you can store images and other types of text inside of Jupyter Notebook. So you would see that the file extension is IPYNB, which stands for notebook. This is not a Python file, which is some people tend to forget. Other things to note is we create a cell by clicking this button, and we add more a cell which you would run individually. That would be a lot of Python code or a script that you want to use. But again, this was covered in the prep course, so hopefully everybody has the Jupyter up and running and we're ready to start. All right, so the two things we're going to need is pandas. Pandas, we're going to need the date time library, which allows us to modify some of the fields we have in columns. And then we have Plotly. So Plotly was installed yesterday. So hopefully you have this installed. You won't get any issues when you start plotting things. That. All right, so let's start. Let's first start by importing the CSV. So this should be quite straightforward. We create a data frame variable. I'm going to say pd.read CSV. And because our data is in the same file location as our notebook, we can just type out the file name itself. I should see it. So I'm going to run this and it says PD is not defined. I need to run this line first. I can first run all the cells to make sure that these libraries are first installed. And then it's not complaining, it's happy. All right, so we're going to look at, okay, let's first make sure that we've read in the data frame and it displays something. We don't have to say print in Jupyter Lab. We can just call the variable and it will print on its own. So then we run this, and there we go. We get our, just by saying df, we get our data frame. We try and zoom in so people can see. I move this out again. View. There we go. So just by saying df, it outputs the various columns, and this is what we kind of expect. So we're going to first start by cleaning up some of the columns, as we mentioned. So very importantly, like we discussed earlier in the week, when you're reading in data, we have to make sure that what the data looks like. Comment this out here. Just first see if all the data was read incorrectly. Do df info and run that. And I get an idea of the columns. All the columns are there. Date, rented bikes, hour, temperature, Celsius. So this is really important. It tells us a problem of one of the columns that we effectively want to use. Can anybody let me know which column was read in a certain type that it won't be useful for us at all? Which column was read in as a certain data type, which isn't useful? Data is an object, so we can't actually use an object. It's, as we mentioned before, earlier in the week, object can have various functionalities, but in this case, it would look like a string. So you can't effectively use a string, for example, to search and filter date, right? To look at progression over time. It just sees it as a string. It's not actually useful. So we have to convert this date column, or this column that's added, into a date structure. And that's why we have imported this library here. So we can do that. Anything else that might be problematic? We have date, okay, months of rated bikes is fine, is 64. The hour we will sort out a bit later. All the numerical data seems correct. It is a numerical, so we can use it effectively. Season is fine. That is categorical data, so that's just the 4 seasons. Is holiday is functioning. These are objects too, so we don't really want to use an object just yet. We will convert this to Boolean a bit later, but again, doing a df.info is really useful. This tells you how the data was read in, especially the data type. So always important to just check the data types for all the columns before you do anything. Let's do a df describe as well. These are built-in pandas functions. You can just get a feel of the data or how it was read in. So df describe, and just describes the data for you, does some statistics for you on the numerical data. The categorical data, obviously, it won't show you anything useful. But again, these commands were, we went through this in the prep course. All right, so the first thing we're going to do is we're going to clean up the date column. We're going to make it, give it the actual date qualities, put it that way. And to do that, we can say df date equals pd dot to date time. So we're effectively converting this column from object or string to date time type, date time. And what column do you want to do that to? It is df, the date column. It is the date column, and you also have to mention the format. format as well. If it's not default, so the format is it's first the %d for day, then %m for month, and %y for year. I think that is correct. Okay, let's let us. I'm missing a quote, so it's complaining there. There we go. All right, so let's just do df info again, just to see if that column specifically was changed. Let's have a look. There's a complaint. Did I do something wrong with my format? I'm missing this one, and then backslash and backslash. I think that is, yeah, I'm missing a backslash, I think. Try that again. Didn't complain with anything, and now my date column has been converted to the datetime format. So it's actually useful moving forward. All right, so something that is also is going to be useful, but later on is not just having a date, column on its own, but also date time. So we can look at how things might change specific to period in that day or period, or maybe like a weekend or something. So after we're going to join the hour to the day or the date specifically. So in that sense, we can create a new data frame called date time. Date time, and that is going to be equal to, and this is just adding two strings together. So we can say df date and add pd dot to time delta. So we're taking our column on our column, and the unit is hour. So it's simple string manipulation with adding two strings and adding it ultimately to a new date column. So I'm going to just copy this here to see if we get a new column. We can also do df actually, just what df does. On it and type it in. Oh, date. I also make mistakes. So what we have here, I think it is there, I think just at the end. Yeah, there it is. So now we have a new column called date time that has the date and each hour that was given to us in the CSV file. So this will allow us to plot the data relative to the date and time specifically. Okay, two more columns we just want to modify to make it easier for us to filter and query in pandas. Is we want to map is holiday and is functioning to a true and false Boolean type instead. You can keep it. But then your condition will be, you have to check that string each time. Is it holiday or not holiday? Whereas if you just change it to Boolean, it saves you 1 or 2 lines of code. So just a better approach to keep a conditional variable as a Boolean. So how do we do that? Well, we just get access to this data frame or this column again. Is holiday, and we say equals df is holiday. Do we simple string replace? So it was no holiday. No holiday. We want to map that as false. And then the holiday string, we want to map that as true. Close curly brackets, round brackets, and the data type is going to be bool. So I will copy this code into the chat for our break. So if you're struggling or for whatever reason, this is the command you use to replace it. So to so I don't have to that doesn't. I actually wanted to copy this. Cut cell, copy cell. There we go. So instead of typing out the same thing, because we're going to do the same map for functioning, is functioning. We're just going to replace the words here. So is functioning is functioning. And is functioning. Now, this type of cleanup is pretty standard with any data we have. You cannot just look at any data set and just work with it. You have to prepare it to make it useful for you. So this is all part of it. So these were the text we have is just yes and yes. Okay, well, or no. Yeah, it's funny if you say no is true, right? And this is going to be yes. It's true. And it's also going to be Boolean. Cool. So let's see if that if my code worked correctly. Just remove this df over here. Top it up. Run it. No complaints. This is a warning. Or replace is deprecated. Okay, well, can still use it. Okay, let's have a look. There we go. It has mapped correctly. So is holiday is functioning is all working, and we can use it a bit easier. Now we only really want to use the data where the service is actually working. So we're going to do a query. So we're going to say df is df.query. Our favorite pandas command. I can just say is functioning. Just like that. If I didn't map is functioning to true and false, how else would I do this with query? If I didn't map is functioning to true and false, what would this command look like? Yeah, so like there's two equal signs, and then like we did in the pipeline, the two equal signs are then equal to that. It'll be yes. Well, we only want the time that the rental, service is functioning. So it'll be is functioning equals yes. So see, go through some questions here. But this is ultimately what we want to use. So it takes away a little bit of coding, but you'll see later on it makes it a bit easier to use at some time. I can show you how to remove this warning as well. It's not too necessary, but we'll do that a bit later. So now I have my data and I can and it only shows the data set where the service is actually working correctly. And then we can start visualizing that as well. So before the tea break, let's plot something because we haven't actually plotted anything yet this week. So let's just create a plot so everybody's happy. So we're going to use plotly and plotly express, and I gave the alias as px. So I'm going to say px.line. It takes as input the data frame now that we've queried to make sure it's only for the functioning time the service is working. So my input is going to be date time, and I'm going to plot that versus number of rented bikes. And this should give us a pretty clear idea of the data, it looks like. So let's hopefully that works, and let's run it. Oh, it doesn't work. What did I do now? Okay. Bikes. I think that one should work now. Just thinking. There we go. That is a pretty clear idea of data set of the 2 years from 2017 until 2018. So we'll analyze this further after tea break, but you can clearly see already trends popping out just from this plot. But we'll stop here and we'll continue after the tea break. We're going to post my code in the chat in announcements. So if you struggle to follow, you can take the code. So it's this one. All right, is everybody ready to continue? So let's go through some questions. First one that I put here was this just removes any warnings in your code. So if you put this at the top of your code, pd.setOption future no silent downcasting is true. This removes the warning that dot replace what is being deprecated, which means soon it will not be used in the future versions of pandas. So just a warning not to use it and use something else. But this version still works. So this just removes the warning. The questions here. When you have a data set that's too large, 100,000 entries, is it a good idea to sample less data entries, reading in entries in steps of 10? This is actually called, I think it's called chunking in pandas. Pandas has a specific way to read in very large data sets. So I think it's called chunking. Somebody can remind me. But there is a specific way to do this to reduce your computing effort required to read in all the data and do some computations. Yes, there are ways to do this specifically in pandas. I think it's called chunking. We don't cover handling big data or large data sets. Yeah, so it's called, you can specify this here. I'll share my screen. There are other libraries that actually that handle large data sets a lot better. Pandas is good enough for in most cases. Krishna. Yeah, so as Krishna mentioned, when you start working with very large data sets, it's better to start moving to high performance computing, which allows you to read in all data in one go with no issues. So it's also a very good point. But again, if you want to test locally, you can. Pandas gives you that options. There are other libraries, Python libraries that handles big data a lot better, but we're not covering it in this course. Jupyter's causing my PC to lag. It's many things can do that. So sorry, I can't be more helpful. Can Streamlit display elements in a notebook during app building? Streamlit isn't designed to display notebooks. So maybe it is possible, but it's not really the purpose. You can run Python snippets in Streamlit if you want. People can interact and change code and whatnot, so you can do it in Streamlit. But I've never seen people use notebooks in Streamlit. Zoom in, zoom in, zoom in. Access denied. Okay, I'm going to report that. Is the reason why the Y in the date format is in uppercase. Yeah, the Y includes the full year as far as I can remember. What does date time do? So this is just string manipulation. This adds the date column to the hour column. This is all that it does. Postcodes, I've done that. So if there was an entry 21.5, would change to 21.3. Well, try it out and see what happens. What other columns is holidays function to describe to data? Like, is holiday means that the day is an actual holiday? Yes, it is. People are not working. It's a holiday day. And functioning is the bike service is functioning or not. So that's what it means. Okay, I need more information than this. Is this a bit extra? Yeah, you can use it as well. You can use lambda functions if you want instead of using replace. Okay, let's continue. We did this plot, so and the plot is versus time, as this means specifically per hour. And this shows the amount of rented bikes. So it's quite clear that there are, maybe two specific regions or times that is the busiest. Remember, Seoul is a city in South Korea, so it's Northern Hemisphere. So the amount of bikes rented, for example, in June is summertime, which is what you expect. So you can see as things go in the quieter part of the year, also the cooler parts, people rent the bikes less. So these trends are to some degree what you expect. That the summer times get busier. There's a bit of a dip here for some reason. We have to analyze a bit more. Why is it a dip? Maybe it's another holiday time or some other reason. But definitely summertime, the amount of bikes rented is the largest. All right, so instead of trying to access the data per yeah. Instead of seeing per hour, we can also look at it per day, maybe just to get some finer insights into the day information. So we can aggregate the information by saying by day equals, we can use group by, which we're familiar with, group by date. So what I'm doing is I'm taking all the measurements for a single day and putting them together. So you don't have each hour combined, and I'm taking my data frame and grouping by date and summing the rented bikes. So it's maybe looks a bit cleaner than what I currently have. So group by date as index false. Don't worry about the index. Aggregate. Put brackets in rented bikes. And I want to sum that. I think yesterday or the day before we did mean average, so now we are using sum. And now let's draw this plot. The aggregated bike rentals per day, so we can say by day. And X is still date. Y is in rented bikes. Okay, hopefully I didn't make a mistake. Let's run that. Mistake. I think I said data, not date. Mistake. And this looks just a little bit cleaner instead of plotting per hour. in this time, during this time period, we just aggregating each day. So we know the total numbers per day, and we're plotting this versus time. So again, the trends are quite similar, and you can see these dips from time to time during this period. So what do you think? You might not, just your first gut feeling. Why do you think these dips? What do you think these dips might refer to from time to time in a data set? What do you think these dips mean? Yeah, this is from, we haven't excluded any time of year. It's just, for 2 years, these are the dips that we are seeing. We have a peak, obviously, in summertime, in June, July. But what are these dips do you think it might be?
Holidays?
Possibly holidays, yeah. We haven't excluded that. So it could be holidays, could be weekends, could be times that are just not that busy. Could be rain as well, thanks you, Kavir. So it could be based on the weather conditions. Could be a storm coming, could be many things. We haven't, delved deeper we haven't used all the data yet to understand that. Decline in demand, maybe something happened to the shop. You don't know. So we can see this is more digestible. We can see also there's some seasonality in this as well. As I mentioned, people are not typically biking too much in the winter. Maybe it's raining a lot, and they prefer, the warmer weather. So now let's look at trying to plot the seasonality as well to kind of see this a bit clearer. So df.group by group by date and season. So this is categorical data. We have this in the data set, which we can use. Again, index is false, we don't need that. We are aggregating in the same way. I want to rented bikes. And rented bikes and rented bikes, and it is aggregating by sum. Let's brackets. Now let's plot this. So this plot specifically is trying to just distinguish the different seasons in the plot. So you can see this seasonality change of the data. So by day, season, X equals date, and Y equals in rented bikes. And to distinguish the different seasons, we're going to add another parameter called season. Let's see what we get when we run this. Another error. There you go. So we can see the different seasons in this plot: winter, spring, summer, and autumn. And this is kind of what we expect people in the warmer weather climate will cycle during this time. All right, now we looked at just number one rented bikes versus time. Let's look at the other parameters. We also have weather that also has an effect. So let's just take noon rides, for example, as one of the parameters we will compare it to. So noon rides equals the query, and hour is going to be to 12. So I want to query the observations at noon. So again, we want to use a scatter plot here, since we want to find the relation between the two variables, that is temperature and rented bikes. So this is when we use a scatter plot. So px.scatter. This will maybe help us gain insights. Is there a relationship between temperature and the amount of rented bikes? So X equals temperature. X. We can also add a trend line. Well, we'll add a trend line afterwards. This is first have a look at the data. If this, I spelled this correctly. Of course, it didn't. X. Sorry. So yeah, there you go. There we go. So this is a scatter plot. This is temperature versus the amount of rented bikes. So is there some relationship between the amount of rented bikes and temperature? What is it? What is the relationship between the two? Yeah, so I'll let the what is the relationship between is there a relationship? Is there a relationship between temp and rented bikes? So Bivar said it is positive. Sure, there's a positive correlation between the two. Okay, I need a bit more insight. So what does that mean? Obviously, when the temperature is pretty low, there are far less rented bikes. And as the temperature increases, so what, like 20, 25 degrees, we have the peak amount of rented bikes, 22.9. But once temperature starts to increase too much, you can see there is a drop-off. People stop renting the bikes. So we can clearly see that there is a relationship between the various between temperature and Celsius. Sorry, temperature and the rented bikes. So to add a trend line, you can quite easily do that with Plotly. So there are various ones you can try. The common one is using low S. Can't remember the parameters for it, but it gives you pretty good trend line. Trend line. There you go. So it's a fairly good fit. And what is useful for trend lines is you can do predictions. You can do any kind of so it's useful to have trend lines to do predictions. All right, so I have done the temperature and rented bikes. Now I want you for the next 10 minutes try to find the relationships, if there is anyone with the other parameters. For example, there's a whole bunches like wind speed, humidity, and rainfall. Try to see if pretty much using identical code here, is changing one of the parameters. That is a hint. See if there is a relationship between the various other weather parameters. So if you get stuck, you can always have a look at the other parameters. You can type df.info if you've forgotten what they are, but this is now you look at humidity, wind speed, visibility, dew point, all these. Which do you think are more obvious than others? So can do that now for the next 10 minutes or so, try to find trends if they, or any relationship between these other weather parameters. Yeah, I'll post my code so far in the in announcements. So the one you actually need for this little exercise is actually just this over here. The rest I'll post later. Oh, you didn't? Okay. Yeah, so this is the one you need in the chat to kind of investigate the other parameters and see. So if you do find one, you can post it in the chat. If there is any relationship between the others, let me know. Cool. So has anybody found other correlations from the data set? I see Mzameli says rainfall. Was also something that they found. So let's have a look. Let's copy this. Is it rainfall? See. Doesn't look right. On-time warning. Counted in divide. Interesting. Okay. Well, it seems rainfall has very little impact. Solar radiation, higher radiation, the more rainfalls. Okay. And just DF. Oh. But there are no other correlations. Wind speed. Isaac said wind speed. Let's have a look for wind speed. Wind speed. Well, it's a bit difficult to draw any conclusion from this, but all over the place. Any other correlation for weather? Solar radiation. What do you think this is solar radiation? So if you do I mean, a trend line would, I mean, there's nothing really here to gather from that. So it's the solar radiation. Yeah, there's a slight trend. There's a slight trend, possibly. But I think the clearest one is obviously the temperature versus number of rented bikes. Do we have to use a scatter plot, Dumisani? That is an excellent question. If we want to find the relationship between two variables, to find a correlation between two variables, a scatter plot is the ideal plot to use. Something to the visibility. I wouldn't really. There's nothing here that's. I wouldn't really say much you can use here as well as information. So it seems temperature. What about snowfall? Anybody try snowfall? I would think. Also note that the hour also can have an effect as well, because I made this at noon, so maybe the data doesn't reflect everything at noon. Yeah, snowfall as well, not much useful there. Okay, so it seems that temperature is the one data parameter for weather that is most useful for us. All right, so let's carry on. Oops, wrong one. All right, so let's look at one daily usage pattern. So we've kind of looked over an entire period, 2 years now. Let's look at on a day-to-day basis, since we have per hour, what the data looks like. So I can create a new variable called time of day. the DF in group by hour. So how many hours are there in a day? Yes, silence. So we should see 24, right? And what type of plot should we be using? Well, I'm going to use mean here, and a bar plot would be most useful because we have a fixed category we want to kind of understand. So we will use a bar plot. X equals hour and y equals rented and X. Let's look at this. Where's my, which one? Oh, calibration. All right, so this is per hour. So this is over 2 years. We have done an aggregation over 2 years. So we can see we have 2 peaks that people most likely, well, not most likely, that do rent the bike. So this is around early morning around 8 o'clock. This is where they rent bikes, and then also this there's a dip probably around work time, I guess, and then but a dip and increases around 6 in the evening. So this looks like it's correlates to typical work, like a 9 to 5 kind of work day. People rent bikes to probably travel to work back and forth. There's a bit of a dip again, and then seems people are still renting bikes at 12 o'clock at night, and then dips down. And then lowest is around 5 a.m. This is the time that people would rent their bikes at least. So just from this outset, you're telling the bike owner, this is the analysis we've done so far. Like, what advice would you give the bike owner? What report, just from what you've seen before? What would you tell them? When would be the best time to, have the most bikes and have staff to have the bikes available, right? So what analysis can we or trends have we seen so far? It is a question. What trends have we seen so far? Rush hour peak, and also in terms of the temperature wise, it's useful to know based on the temperature to forecast the following day that if it's too hot, you most likely will have less people, or too cold, less people renting. Yeah.
Why is the bike shop open at like 2 a.m.?
That is a good question. It could also be those bikes that are just lying around.
Oh, okay.
In to renting, so that there could probably be another option. But yeah, it's why is people renting in any case at the time? But yeah, so so Bivar says at 18, which is at 6 o'clock, is the best time to have the most bikes available. Bikes need to be charged. Well, I mean, if it's not, we don't know if it's charged or not, but just bikes lying around. So yeah, so this is typical daily usage pattern. Then we can maybe take this a bit step further. This is, I mean, in terms of the whole 2 years. Let's look at the same, almost like the same daily usage pattern, but per season. So I'm just going to copy and paste this code here and change it a little bit. I'm going to add season, group by not just hour anymore, but by season. So this data set might not apply to you or your research at all, but hopefully you can take from this certain parts of pandas and data analytics that you can use yourself. So this is all the purpose of why we're doing this. So we can keep to mean, that's fine. Now we're just including season. And we are still going to keep the bar plot. However, we're going to have going to add other plots for the season. So this is a parameter I need as well. Wait, no, this is incorrect. I think this is like per column parameter you need. There you go. So this is now per season. The same analysis, but now looking at autumn, very similar peaks, 8 to 6 o'clock, springtime 8 to 6 o'clock, summertime is the largest, which is what we expect. And then wintertime, I mean, the peaks are still there, 8 to 6, but they are far less. So people are obviously renting bikes far less in winter, and that's one useful insight to draw for the bike shop owner. All right, so the last one is maybe you want to look at a specific time period, like New Year's Eve. Does this change for whatever reason? Is there a certain maybe certain holidays you actually want more bikes? You want to ride around bikes, but more so. Last one we're going to do now is New Year's start. We're going to filter our data, so we are looking at New Year's. So it's 2017, 12, 31. That's the hour, New Year's. And so if you're working a lot with time data, you're getting some useful practice here. So 2018, 1st of January, New Year's Day, also 12. So we're looking at 24-hour period for New Year's. And then what you're going to do is, so New Year, New Year equals, can do df.query. Query, so it's going to be date time is bigger than or equal to %, New Year start, and date time is less than equal to oops. New Year's English. So hopefully this works. We don't actually need to explicitly say date time because it's used twice. We can actually say it like this. So we can say at New Year's start and say less than equal to date time. It can do either one. It should work fine, I think. New Year's start, less than equal to date time. End. All right, and then we're going to do a bar plot to see if anything is unique for New Year's. So New Year x equals date time, y equals in bytes. It works. Date time. New Year's. Where's my mistake? Oh, there we go. Yeah. There you go. So for this holiday, we can see that times change slightly. So not 6 o'clock anymore on holiday, but there's quite a big peak at around 3 o'clock. People got, rented more bikes, and then there's a dip. And then around New Year's, people are cycling around, which I guess is understandable. And there's a dip again. And then 12 p.m. is well, in midday, there's another increase. So maybe they riding around as a holiday and they're getting a lunch or something. But yeah, that is pretty much it in terms of analyzing the data. So we can give the bike owner some useful information when to have the most bikes available, based on the season, based on the temperature, based on time of day as well. So it's pretty clear that during the we have 2 rush hour or like 9 to 5 period of time where we need to focus on, making sure that most bikes are available. Yeah, that's it for this analysis. I'm going to share this solution on Canvas. So if you've got stuck with any of this, or you want to look at the code, I'm going to share that shortly. But if there are any questions or comments, you can put in the chat. Hopefully it was quite straightforward. But just more of a recap on Jupyter and just doing a demo on EDA. So let's copy over, see if there are any questions here. No, there are no questions. Everybody seems happy. Can we develop a correlation matrix to monitor the effect of the different inputs and outputs? Yes, you can. There is a built-in, I can't remember what it is, but there is a built-in Python correlation library. Could be from NumPy or the stats library, but you can easily do that, and it gives you a nice matrix. So let me just quickly show you. We have half an hour until the lunch. So we have the notebook solution. You can copy that. This is a solution. You can try it out with all the answers. And then you have a quiz that you need to start now. It can take time before lunchtime. If you want to, again, go over the code, you can. But please do the quiz for the Jupyter Notebook exercise that we did. Yeah, and that's it until lunchtime. We're going to have Norman and Fupi doing a bioinformatics demo. Again, it's still fairly generic, so if it's not your field, it's fine. You still learn quite a bit about data science in general. So we made these demos quite generic for you. But thank you. Please do the quiz, and then we'll continue after lunch.
Hello, everybody. Hmm. Can everyone see my screen? So, my name is Namlinda Lola. I'm going to be taking you through the computational literacy for bioinformatics. So the first thing that I would need us to do is obviously to set up our environment, because we're going to be using a separate environment instead of using the base environment for our installations. So if you don't have, is it bad? Is it better now? Okay. I would return of Anaconda, and that's only on your class time, on your normal PC. So if you are using Windows, it would be better for you to use the Anaconda prompt for this. And then if you're on Linux or Mac, then the terminal should work. So if you don't have the Conda set up on your PC, the instructions on how to do that are on this link. So you can just go and go through those instructions and follow them. So I'm going to be using the terminal for this demonstration. I'm just going to open my terminal. So before we start with anything, you should be on base, not be on any other Conda environment. And then we're gonna be doing a copy and paste, so you don't have to type anything. All the instructions on how to do this are available on Canvas. So if you can just go under the computational literacy for bioinformatics on day 4, then you should find this. So obviously, I included here the standard method to create your Conda environment, but we don't have time for how slow Conda can be. So I'm just going to be showing you guys a quick hack on how to get your environment working. So I'm going to just move this. So if you're going to be following along with the demonstration, you're going to have to open your terminal. And once that's open, then I can start going through the installation. So this is my terminal. As I've already mentioned, I'm on base, so I don't have any conda environment or any environment activated beside the base. So that's why I can be able to create my environment from here. So I already have, sorry. I already have the bioinformatics demo environment, so I'm just going to be using a different name just for this demonstration. So I'm just going to call it bioinformatics, and we're going to create an empty environment because we don't have time. And my conda has issues because I tried to install Mamba on base, and just to show you how slow conda can be, I've been trying to solve this for the past 2 hours, but it's still trying to solve. But conda works, so that's all we need. Oh, bigger, okay. Better. Okay. So what I did was just to run the this command, which is conda create, and then this n just tells conda that we're creating a new environment, and then this is the name of the environment that we are trying to create, and then the option this option yes, it just means that we're telling the prompt that it should just go through with whatever, and it shouldn't ask us if we should press yes. So that's fine. I'm gonna then activate my empty environment. I'm just gonna clear because I'm sure it's not gonna be visible. And then I'm just gonna activate my environment using conda activate the name of my environment, which is bioinforme. Things I don't know how many S's I used, so I'm gonna have to go back. Just copy that. And then Control C, then go to, and then conda create, conda activate our environment that we just created. So now that's active. The only thing that it has is just Python. So now what we're gonna try to do is to try to install our tools that we're gonna be needing for the practical that I'm gonna be doing later on. So because conda is, so we have conda and then we have Mamba. So Mamba is just a fast replacement of conda. So but you need conda to be able to install Mamba. So I'm gonna use conda to install Mamba onto my activated environment. Is the order not coming through everywhere? Let me just check. Okay, I'm just gonna ask Benjamin to fix the file if you're saying that you can't access it from your side. Okay, so because I want you guys to follow along, let's just solve the problem that we're having with the files right now. Publish this. Okay, it's fine. I'm gonna restart from scratch. I'm just making sure that you guys can access the files. Okay, so I just published the files, so you can just check if you can access it from your side. But even if you don't, I'm just gonna do the demo and then you can do it on your own time. So someone asked that I should start afresh because they're not understanding the commands that I'm using. So I'm just gonna do that.
Mali? Yeah, let me check.
So I'm gonna start this from scratch. So the first thing that you should do when you have Conda already installed, because for you to be able to run this command, you have to have Conda installed on your base. So you call Conda and you tell it to create a new environment, and then you give it a name. I'm calling mine bioinformatics. And then I'm not installing anything on my Conda environment. And then I'm giving it the option yes, so that I'm giving I'm telling the prompt to always just go ahead without asking me anything. So you're gonna wait for Conda to solve for the environment. So now I have my Conda environment installed, but it's still empty. So the first thing that I'm gonna do is to activate it, so I can start with my installations. And the only reason why I'm taking this longer route is because we don't have time, and Conda installations usually take a bit of time.
Gosh, there might be something wrong here. I can't, the speakers aren't outputting anything. Normally it's busy with the presentation and you can't hear anything on this side.
I think you're not muted, viewer. So now that I have my environment installed, the first thing that I'm gonna do is to activate it, which using Conda activates the name of my environment. And then let me just clear so that you can see. So let's start again. Okay, no, it's fine. Let me just do the demo and then you can do it at your own time if you're not going through. So now that I have my Conda environment installed and activated, I can then move on to installing Mamba onto my environment. And the only reason why I'm doing that is because Conda unfortunately is not as fast as Mamba. So I'm just gonna do Conda install Mamba. And then the option C is just telling Conda which channel to pull this from. And the channel that it should pull Mamba from is Conda Forge, and that's because that's where Mamba is hosted and located. So just so that chats. So when you're using Windows, you should be using an Anaconda prompt. So if you don't have that, there's instructions on how to do that on my on the page that I shared on Canvas. So if you're using Anaconda prompts, then you won't have to install on any of the Anaconda dependencies, because the Anaconda prompt just comes with everything installed for you. So it seems like Conda managed to pull Mamba for me. So now that I have Mamba on this environment, just clear. So now that I have Mamba on this environment, I can then use Mamba to install my tools instead of using Conda. So the first thing that you should do, especially as a bioinformatician, we don't have the channels that we find our tools are not really the channel that we find our tools is called bioconda. So you should add it to your config file, and this step here just outlines that on how to do that. So you're gonna start by adding the default. That shouldn't take time. So you only do this once on your environment. So I've already added this onto my default environment, so I don't have to do it again. So you only do this once. And then from there, you can be able to move on to then installing the packages that we're going to be needing. So I'm using Mamba to install my packages. And I already see that I'm going to have an issue because of that. So I'm going to install, so I'm telling Mamba to go to biochannel and to bioconda and also Conda Forge and fetch a package called setkit and a package called semtools, a package called bfc tools, a package called CSV kit, and the spider kernels, because I'm going to try to run my spider from my activated Conda environment. So just remember install that. When I get a lot of warnings, but warnings, if it doesn't terminate, if the warning doesn't terminate whatever that you're trying to do, then it's not really, you can be able to ignore it. So Conda, Mamba right now is trying to fetch the packages that I just put now. So this is going to take a minute. So thingy chat, I'm pretty sure PS Full tool does not work on Windows. The install does not work unless you're on a Mac. Well, the reason why we are using Conda environments is because it doesn't matter where you are, and as long as you installing that Conda environment, it's gonna work. So that's the reason why Conda environments exist. Because we're running away from the whole it does not work on my PC, it works on yours. So now I have my installations done. Just to check if all what is it, BSC for tools, if it got installed on my thingy. Just gonna say BSC tools. It's very long, so it's gonna take some time to print out all the help function. So just to show that the installation was successful, you are able to call your BSC tools. So now the next thing that I am going to do is take you through the demo that I wanted to do today. So I decided to include the slide so that I can be able to explain to you guys what bioinformatics is and what we do, and how we use how we can use code to make our life easier and faster. So most bioinformatics work begin with with a biological sample. So this can be a blood, tissue, or cell. So this sample is taken to a wet lab where DNA or RNA is extracted. So once that genetic material is isolated, it is then prepared for sequencing, and the sequencing machines generate then raw data, and that we then store that raw data in FASTQ files. which are not readable by humans and require specialized software to be able to work with them. So from this point onward, the work moves into bioinformatics. So the data is processed through several steps. This includes quality checking, the cleaning, alignment, and also just analysis. And then at each step, you get data in different formats. Like for an example, here you get your FASTQ files, and then they go through the pre-processing, which is just quality check, and then they still remain your FASTQ files. And then how we store them, because FASTQ files most of the times are large, so we usually store them as BEM or SAM to just reduce the storage that they occupy. So if you're still not going to be doing any of your analysis, then you just keep your files as that. And then after that, we move on to extracting variants from those files. And the files that we keep our variants are called VCFs. So that's the whole workflow that we follow. So as you can tell from all this workflow, there's a lot of ETL process that's happening. We're extracting data, transforming it, and also reloading it or storing it into a database. So obviously that depends on different packages. So as a result, that's the reason why we need Conda environments, because then they isolate the environment. I mean, they isolate the environments for us so that if you're dealing with filtering, you can have an environment for that. But also there's pipelines that have put this together. So you get the whole process in one pipeline. So you can imagine how many packages that pipeline might be depending on, which is then, that's the reason why most of the time we just move to using Conda environments. So what happens with Conda environments, what you're doing is you telling the system to put away a certain space, which you want to call the environment, and then in that space, you want to put all the packages that you might need to run your analysis. So that's basically what I do on day to day. So I get installation requests from users across the country that they're trying to use the cluster. It'd be a tool or a pipeline, or maybe asking me to create a Conda environment. As a result, we have like more than 150 Conda environments on the cluster now. So you can imagine how big that's going to grow as more bioinformatics tools are developed. So yeah. So the next thing that I want to take you through is how to then perform this ETL process on our biological files, which is FASTQ files, your FASTA files, as well as your VCFs. So the next thing I'm gonna do, I'm gonna go to Spider just to do the demo.
Hi, Namli. We're receiving quite a lot of questions on the chat about the environment. some of the things are not running. So not sure if you can check that.
Okay, let me just go to chats now. Okay, let me start from scratch. Okay. So how do we solve this? In order for me to know what we're solving, I'm gonna have to know what you ran, hey? So what did you put? So let me just start from scratch. The last thing in mine shows that sacred division is not recognized. Well, did you install it? With did you run the member install? Okay, let me just go back to doing Conda, hey? Because it seems like everyone is having a lot of my environment. I'm on base and I have my Conda installed already, right? And then the first thing that I'm going to do is to say, well, use it to remove one C or one S. So I'm then gonna tell Conda to create a new environment called bioinformatics, and then I'm gonna tell it to say yes to whatever prompts that it's trying to ask me, right? And the reason for this is because Conda is very complicated to deal with, but it's such a valuable skill to have. Because once you master it, it makes your life so much easier. So, did everyone get that? Works, right? Okay. So if there's someone that it works on, it means that I'm not lying at least. Okay. So now we're gonna move on to, I'm just gonna clear because my screen, honestly. And then after you created your empty environment, remember we just created an empty environment, we didn't include anything. So the next thing that I'm gonna do is then to say, Conda activate the environment that I just created, right? Right. So so I should type, not paste. Okay. So after you've then activated your environment, you can then start with your installations. Now, I don't want to be using Conda to do my installations because it takes a long time to solve for your environment. So what I would rather do is then to tell Conda to install Mamba for me, right? So I'm gonna say Conda install Mamba in this environment that I just created, right? Don't mind the leaves things. So if you are using Windows, don't use your PowerShell. Like use an Anaconda. It's called Anaconda prompt. If you can go to Canvas. On top, I did include instructions on how to install that if you don't have the Anaconda prompt on your local machine. So with Windows, I using Anaconda prompt. If you're stuck, it's fine. I promise you, whatever code that I gave you works. So you can just go through it on your own time and paste the code. So I'm still waiting for Anaconda to install Mamba again. But this is taking too much time, and I feel like I want to move on to showing you the main aim for this demonstration. So I'm just gonna use so the code, you can get it from Canvas. Can everyone access Canvas? Because you can just open the code from Canvas and then copy it from there instead of reposting it on the chat. So now that Conda has managed to fetch Mamba for me, I can then start with my installations. So I'm using quite a number of packages. That's why I need to copy and paste the rest. It's not gonna work. Okay, sorry, I will do that next time. Anyways, so the first thing that I'm gonna do is to make sure that my spider can be able to find the environment that I'm gonna be using right now. Because remember, in that environment, the whole thing that we were trying to do was to make sure that when we call for the packages that we need, they are installed on our environment. So that the whole point of doing the whole Conda create the environment was for us to set this up before we start with our analysis. So the first thing that I'm going to do is to make sure that Python, sorry, let's close this. To make sure that Spider is using the exact environment. I mean, it is seeing the exact environment that I'm trying to use so that it can be able to see whatever packages that I need. So I have my bioinformatics demo here. So you press here to select. I have a number of environments. These are just different environments. So I'm going to choose the one that I just created now, which is the bioinformatics demo environment, right? Now that's done, I'm gonna make sure also, because so with the attachment that I did on Canvas, I also included some files that you're gonna be using that you're gonna be needing to do this demo. So I'm just gonna make sure that I am on my on the directory that has my files, which is this one here. And the reason why I'm doing that is because in the rest of my script, I didn't put full pads. I just used I just did my script as if I'm working on where I'm working where my working directory is where my scripts, I mean my data is. So if you, so guys, you don't have to like do, you don't have to code along if you're still stuck. So you can just follow along with what I'm doing right now. And I promise it's gonna make sense because bioinformatics is really just English, right? So the first thing that I'm gonna do is obviously what I just did now, to set my spider interpreter to make sure that it's the one that's within the environment that I just created now. And then I'm gonna start with running. So the first thing that I'm gonna do, okay, so I'm using Spider for this demonstration because most of the things that we do in bioinformatics, we do it on the command line interface, but you guys haven't been introduced to that. So I didn't want to go through the pain of having to introduce how to move around the interface. So that's why I just chose to do Spider. So in order for the commands that you work with on the on the command line interface to work on Spider, you have to make sure that they start with that exclamation mark. So that's the reason why all of my script starts with the exclamation mark. So remember when I was installing, I installed quite a few packages, and one of them was CHPC and the other one was BFC. I always mess the pronunciation of this tool, but yeah, and then the other one is the CSV cut. So the first thing that I'm gonna do is to check if everything that I installed can be seen from my Spider environment, right? So I'm just gonna ask which CHPC and then run that. Let's just move this up. So it's telling you that it's using the CHPC that's installed under that environment, the bioinformatics demo environment, which means we can be able to call it because it's there, right? And then the next thing is obviously to then go through the second one. I'm also just checking for the tools to make sure that all the tools that all the tools that I'm gonna call later on my environment, right? So all of them are there, and I can also see all the data that I need that is there. So I attached the data on Canvas, so you can find all these files there. So I just zipped it. You can just unzip it. But they are not really big files. It's just example files because I just wanted to do the demo. It's not really like real FASTQ files or FASTA files. So of course, as I've already mentioned, I work in a cluster, which means I deal with a lot of installations on a daily basis. And there is no way that I can be able to know exactly what all the tools that are installed in the cluster do, right? So this is where the help function comes in. So all the tools so all the developers, especially with the bioinformatics, all the bioinformatics software developers, what they do is they make sure that whatever tool that they develop, they make sure that the documentation can be used even with it can be used even by a beginner. So that's why they put the help function. So if the help function is still not really clear to you, you can also go to where, like for an example, with CCAT. So all of these things are online, right? So CCAT. So if you can just go to their website, just the Git. If you can just go to their Git, there's docs there. And with the docs, you can find almost everything, every function that they developed in their script. You can find them on the docs, how to use it, what options are a must for you to put, and all of that. So they always make sure to include it because they know that we're not all software engineers and we don't all understand code, right? So with the help, as I said, it gives you like what the tool does. Okay, so just to give you a background of why we use these tools in bioinformatics. So when Benjamin was doing the ETL with you guys, what he did was to define the functions for you guys from scratch, right? So in bioinformatics, you hardly have to define a function, especially if if you're just using it to pass data, you hardly have to define it from scratch, right? So we have these software developers, software engineers that have spent so much of their time trying to make sure that the function of what you're trying to do works, right? So if, for an example, we didn't have CCAT, what you would have had to do, like for you to be able to find stats of a FASTQ file, is to develop a function called stats, right? Or a module called stats that can then be able to calculate the stats for FASTQ file for you. But that is not something that as a beginner you should even be thinking about, because the tools that are out there for bioinformatics transforming bioinformatics data, they've been well studied, and there's been a lot of publications that have been published to prove that they work. So you almost never have to start defining the function from scratch, right? Stop. So, and I've realized that obviously if you're a beginner and you get to attend, because I also attended a summer school when I started with my master's, and they took us through Python, and it was so confusing because you're like, but how am I going to use this on my files? Because most of the time, which makes sense, they always start with introducing you to pandas, how to view the CSV file, and how to use pandas to manipulate your files, how to define those functions. And then obviously the first thing that you might be thinking is that, oh, which means before I even touch my data, the next step is for me to learn how to define this function so that they can be able to work for me. But that's never a case. Like even for me right now, I'm busy with my PhD, and it's only now where I'm defining functions from scratch, because the only reason why I'm only getting into doing that is because I'm trying to publish a method that has never been used, you know? So if a method has been used before, like for an example, you just trying to go through your FASTQ file and trying to see if the base pair in that FASTQ file pass a certain quality. So if you're just trying to do something that's that simple, then there's already pipelines that people have worked, like for the one that I just showed you right now, like they have almost, I think, 22 contributors to just make sure that all the scripts that are here and everything that's here works for you when you try to install it on your local. So for them to be a beginner and thinking that you can be able to develop a function that's so good for bioinformatics tools, that's so good to pass bioinformatics tools that you can be able to, it's something that they haven't thought about, is very unlikely, unless of course it's a situation like what I've just mentioned. So now you have your secret, right? And then the help function. So if you do the secret help function, you get a lot of text that tries to explain what the package does, right? It's very then important for you to, before you even start with touching your data, for me, I feel like it's more important to understand the tools that you might need to even like analyze the data or transform the data into a different file, if that's what you if that's what your research question is about, right? So with CCAT, it's as you saw, it has like 22 contributors. So it's a very big, large pipeline. It does a lot of things. As a result, it has what we call subcommands, which is then you can only be able to access that subcommand help if you call CCAT, which is what I'm trying to do here. So CCAT has a module that deals with stats. So that's the module that you can use instead of you trying to define, like, let's say you have your FASTQ files. Instead of you trying to define how your algorithm should decide on which base pairs should be kept on your files for downstream analysis, you then have to go through check the secret stats and see what options are available for you to be able to get your stats. So for an example, if you were to run secret stats right now, also print out a hub function. This is not just text. They all mean something, hey? So here it tells you exactly which options that it needs for you to specify for it to be able to calculate stats for you, for an example. Like, so if I were to take the example that you guys did with food and what are the foods? Yeah, the determiner for the top apps were the reviews, right? Like how many like you defined how to set the rules. So the function, what it does, it does that for you already. Like it sets the rules for you already, because obviously these people have been working with these fascicles for a long time, so they know them better than you do. So they know exactly what to specify to get high quality files. So the next question will then be, but how do I know what parameter to set for this? That's also that's when publications comes into place. Like if you go through a publication, they always include their code or where to find their data if it's public. And also they also always, most of the time, they have like their code hosted on Git, for an example. Then you going through that code and trying to and then if you have those questions, then you can simply just go through their code and follow exactly what they did. And that's the best teaching mechanism that I can think of. And then, so CCAT also has a module that's called seq. This one deals with your sequences. So it also has a module that you can use to convert your FASTQ files to a table, for an example, or you can convert your FASTQ files to your FAST files. So it does this for you already. So you don't have to do anything beside just giving it the path to your file, right? So so the next thing that I'm gonna do is just to show you how it works. So let's say you have, oh, another thing that I forgot to mention is with bioinformatics, the bioinformatics files, it's not the kind of files that you can just open your text editor and open them with your text editor. They have design softwares that were designed to specifically open them. So if you open it, for an example, if you were to take your FASTQ file, it's something that I did yesterday. If you were to take your FASTQ file and try to open it on your text editor like Nano, for an example, and then try to save it after that, it's no longer a FASTQ file. And I feel like it's something that most people fail to understand, because most of the time you might be saving white spaces that you can't even see with your naked eye, which is why if you ever want to read this kind of files, you should have the tools that are specifically designed to work with them. You should use them to work with them, even if it's simple things like you trying to open it. So, and there's almost never a reason, and I can even stand on court for this. There's never a reason for you to open your FASTQ file like on your text editor, because even if you open it, it's going to be showing you a bunch of characters that your human mind can't even understand. So there's never a reason. Like you opening it, you're just making it harder for whoever is going to deal with those files next. So yeah. So I can. So CCAT comes with, so with CCAT, you can be able to view your FASTQ file, right? So you can just run CCAT and then head, which means print the top sequences that are in there. And then and then this is the file, this file that I have here. So I'm just telling setQ to show me the head of my file. And as you can see, it then outputs it here. So it's just the best way to think of this is this just displays the sequence of a certain gene. So gene 1, but remember I told you that this is just the toy data. So gene 1, obviously they are not this short. They never that short. Well, I haven't dealt with all of them, but I've never seen one that short. So this is just an example file. And then the next thing that you can do is, so I just want to show you how easy it is to transform your file from one extension to another. So you can just use CKit. Okay, sorry. So this here, what I did was I told CKit to find stats of this file, which is the example FASTA file. And then once it has found the stats of that example FASTA file, it should then go to print it onto this text file. Text, because of course it's just text, stats is just text. So it makes sense for me to use that txt extension. So what Secret did here was it took the stats of the file here and printed it to that one, just to show you that I'm not lying. So sorry, it's FASTQ file txt, sorry. So the name of the file is FASTQ file underscore first stats. What the fuck? Well, this I forgot the extension. What am I doing now? So because it's text, I can hear of or how you can use this file depends on what you're interested in. So another cool thing that you can do with CKIT, if you have your FASTQ file and you would like to store your FASTQ file, you just need the sequences. Let's say the pipeline that you using for your theta analysis, it needs FASTA files instead of FASTQ files. So you can also be able to just use CKIT to do that for you. So the function that does that for you in CKIT is called FQ to FA. There isn't a quiz, it's just a demo. So yeah. So the function that you using to convert your FASTQ file from your FASTQ files into your FASTA file, you can just call so with the you can just call FQ to FA to convert the FASTQ file for you to the FASTA file. Let's say the analysis that you doing need a FASTA file. And the reason why we know that this function works is because there's been a lot of publications that have used it. Like you can verify that through that, because if in science, once something is accepted for publication, we deem it as correct, right? Well, not always, but yeah. So then now, since I'm done with dealing, I'm going to move on to showing you how you can also use these packages to filter your FASTQ files for you. Now, let's say you already know that for whatever organism that you're working with, the base pairs that are good to do your analysis on between 150 and 300. You just need you just need to output the sequences that have a base between 150 and 300 into the filtered FASTQ file, because you know which this is good, right? This is what you want to be working with. You don't want to be working with any file that doesn't have that. You can also easily use, guys, it's bioinformatics, that's but anyways, you can easily use secret to be able to do so what I'm doing right now, what I'm trying to do right now is exactly what Benjamin was doing with you guys yesterday. Or was it Tuesday, when he tried to take you through the extraction, transformation, and also loading process. So what I'm trying to explain is that in bioinformatics, you don't have to, I'm not laughing at you guys, I'm laughing with you. Anyways, in bioinformatics, you don't have to write this function from scratch. Like you never almost have to write it from scratch, because obviously if it's confusing right now, it was going to be worse if we had to write this function from scratch, right? Because in bioinformatics, most of the time we are not dealing with flat files. Like one thing about CSV, like the files that you guys were dealing with, like CSV file, TSV file, is that they are flat files. So that's why you can be able to use pandas to deal with them. With bioinformatics, the files are not just files, right? These files contained our whole DNA, for an example. So obviously, now you being able to take a file that's containing all the positions of your genes on your body, and be able to now try to write a function that will be able to tell which of the sequences which of the base pairs are good and which ones are bad. Obviously, that will take a long time. And the only thing that bioinformatics is about is the interpretation. Like the only thing that we care about is the result, which is why most of, like for an example, if I were to take an example that maybe we might all know, when was it Senbi, when they discovered the new COVID strain. Yeah, I think it was Senbi a few years back when they did the genome assembly and then discovered that. Now you can take that and take it to the government and just be like, oh, here's the file. It contains my new variant, right? So what we use to communicate with the general public is tables and that we use tables and also plots. But for you to then move from FASTQ file, for an example, and move all the way to a table that if you give it to just a general individual, I mean, like for that table to, I mean, for the information to make sense, you should at least represent it in a table form or a diagram or a plot. And that's the whole reason why we have to then do the transformation of move from one file to another so that we can finally get to representing our findings in a table that the general public, in a table or a diagram that the general public might get. So yeah. So now let's say you want to filter out your, you have your FASTQ files and you have your FASTQ file, you want it to only contain only the base pairs between 150 and 300. And also with FASTQ file, the Q stands for quality, which means all the samples that you might have on your file, they already tell you the quality of the base pairs that are in there, right? So with you having that in mind, oh sorry, most of the time we just use 75% as the cutoff. So when you're using like 25%, that means you're only gonna be left with, if you're filtering out all of the ones that have less than 25%, then that means you're gonna be left with only the good ones, right? But instead of you writing a function that will be able to do that for you, you just install the package. So another thing that I wanted to see, which is the reason why I left it like this, is so with all those packages that we use for our installations, I mean, with all the tools that we use to analyze our data, the way they are built, they know exactly how a FASTQ file is. So if you, for an example, you have things, if you have things that I lost my train of thoughts. But anyways, I was still saying that so now you have your new files that only contains your good your high quality sequences, right? So now that you have that, you can then, only then can you be able to then feed it to a pipeline. Because I realized that most of what most problem that most bioinformatics students do is that they get their data from wherever that they're getting it from, and then they just feed it straight to the pipeline that you are using. The pipeline that you are using, right? So now what that means is that, now let me log off Slack because it's kind of like losing my train of thoughts. Okay. Okay, so one thing that I realized that most students do, which is the biggest failure, like the first step of failure when you're trying to deal with bioinformatics data, as I showed you on this, sorry. on this workflow. Like before your data comes to you, it passes through so many people and passes through so many libraries, right? And sometimes, like what I'm doing with my research, I got my data in VCFs. So it already passed through all of that. So now the mistake that you can make as a person who's gonna get there, who just got their data, is to feed it straight to the pipeline that you're trying to use. So the reason why I even opened that is because of this warning here. So it's a warning. It's just I mean it's just white space, so it's not really harmful. I mean it's just a gap, so it's not really harmful. But the reason why we use CPET or whatever specialized tool to even open the files that we are working on is because they know exactly how it should be. So if there's a gap somewhere that's not supposed to be there, then it tells you that, hey, there's a gap here. And if you are dealing with a pipeline downstream that's very if we are dealing with a pipeline downstream that doesn't have that feature of knowing if it's really a FASTQ file, you might even end up getting wrong results, which is that it makes sense for you, like when you get your files, the first thing that you should do, you should pass them through a parser like this. Like for an example, the secret is one of the tools that you can use to check if your FASTQ files are really FASTQ files, right? So yeah. So another thing that you did, another thing that you can do is now you've produced your filtered. I should just make sure I'm here. Yeah. So now you've produced your filtered good FASTQ, right? You've produced your filtered good FASTQ. Another thing that you can be able to do is to only then start performing your stats analysis, because now you know that you've done your pre-processing, and then now you know that, okay, I have I have a file that I want contains everything good, right? And then now you can be able to move on to performing the stats on your file, which is what I'm doing here. So echo is just it's the same thing as print. So if I didn't want to use echo here, I would have just used print and then didn't use the exclamation mark because Python understands print. So echo just says, okay, print that has been saved, right? And then same here, the same thing that I'm doing is to use the option Q, which is quality, and quality you find it on your. Oh, another thing that I should mention is that FASTQ files contains what we call quality, but if you were to open your FASTQ file and try to see where you're gonna find that quality, it's not gonna make sense to you. So that's another reason why you should stick to using specialized bioinformatics tools. Okay, Brian. It's good that there's someone who understands me at least. Anyways, and then here, what I'm doing is trying to find the stats of the file that I just created, and then I'm just saving it to high quality only stats. Also, another thing, I think maybe you guys are gonna understand this better after you've done the bash tomorrow, because at least you're gonna be understanding what that is for. Like this just tells bash to direct everything, I mean the content of what I'm running to a new file, which is called high quality only FASTQ file. And then the next thing is, then I'm trying to find stats of that file, of that high quality only FASTQ file using the built-in function, which is called stats. And then, yeah. And then one thing that I also wanted to show you guys was, obviously with bioinformatics, you are never dealing with just one file. Okay, maybe you might if it's a multi-sample file, but that's hardly a case. So if you are dealing with multiple files and you asking yourself, okay, does that mean then now, just because I'm not writing the function myself, does that mean I'm gonna have to feed all the files one by one to secret in order for me? Like let's say you have you have a folder that's containing like maybe multiple FASTQ files, right? 2, 3, 4, or whatever, more than 2, right? And you wanna perform. So let's say you wanna you have multiple FASTQ files and you wanna find all the stats of all the individual FASTQ files, right? And you obviously don't wanna be typing all like one by one, like getting all the stats one by one. You can use what we call wildcards, and this is something that we use to okay. So something that you use to so you can use what we call wildcards to take care of all the files, FASTQ files that are in your current working directory. So the star just that stands for take all the FASTQ files that are in my current directory. If I wasn't using, if the files were in another directory, obviously you would use like the full path to that directory, right? And then you direct your files to, okay, so the first thing that I did was to create a new directory here that I'm going to be storing my files in because I don't want to be mixing my files with my input files, right? So good practice is that you always make a separate directory to install your files. So once you have once you have created the directory that the new directory that you're going to be storing all your results files into, you can then be able to feed all your FASTQ files into secret stats to perform the stats on all the files that you have, and then direct all of that into a folder called results and a text file called all stats. So because I was doing a demo, I only have 2 files here, but this works for even if you have like 100 files. Only thing you have to do is stats, especially if you're just performing one function of them, then this should be good. But of course, if you wanna be performing multiple functions, then you might think using for loops might work for you. You might consider using for loops. So now I want to see where I finished. So I'm gonna make my directory, my new directory, and call it results stats, and then I am going to tell CHPC to perform stats analysis on all my FASTQ files that are in that directory. So I have 6, so it processed all of them. And that's the reason why we do this on the terminal rather than the spider, because you now cannot see all the information. But anyways, let's move. So now it processed all my 6 files, and just to prove that that really happened, I'm gonna go to my files here. So I called the thing in results state. So I'm going to look for result state. And then in there, I have all FASTQ file stats file that I can be able to then find all the stats from my FASTQ files that I just ran. And then this just says that has been done, just confirms. I just add them as a form of a question, as a form of a comment so that I can know exactly what I was doing. So okay, I think they answered you. So the exclamation marks, you just use them to tell them that, to tell Spider that what you're running is actually a command line. So it's a command line command. Does that even make sense? Yeah, it's a command line command, so that, because obviously if you were to just say echo, Python doesn't really understand echo, it understands print. So to bypass that, we use the exclamation mark. But anyways, continuing. Oh, let's don't put this. But the reason why it's not finding is because I'm here. So you always have to go back to where your data is. Anyways. And then this part here just shows you how to perform. Let's say you don't just want to perform the statistic. You don't want to just filter out your sequences by the base pair. So this you can then use for loops to just loop through your command. So this works the same as just using the start.fastq. So it just tells Python to it just tells Conda to just all the fastq files that are in your base directory, it must perform this function on them, which is the same function that I used up there. Just that up there I used 20 and 300. But yeah, it performs the same function. The reason why I had to just add it is to make you see what you can do if you are working with many files, which is something that you always doing in bioinformatics. So yeah. So same thing here. I'm creating a new directory that just contains my FASTQ files that have been filtered using these options, and then I store them onto my new directory that I made here, which is called land filtered. So called it land filtered because obviously you wouldn't know 6 months later what you did to those to that subdirectory file. So it always just makes sense to call your file exactly what you did. To call it directly so that it can give you a clue what you did to them. What you did to them. And then here is just the same process as now. I'm still using for loops because I'm trying to work through many files. And then I'm just performing the filtering using those options. So this talks to the base pairs. And then this talks to the quality, which is something that's included in your FASTQ file. Secret will know. Okay, maybe if I explain it like this, like Secret will know exactly what to do if you give it that exact command, you know? And to know what to give a Secret, like you then need to go through their help function. I mean, there can be whether they are manual or just their help function. The help function is usually just sufficient. So yeah, so it's just telling Secret to perform the filtering using 100, and then and it's also telling that we only want to keep quality that's above 80%. And then it's also telling Secret is after you're done doing that, can you then convert my files to faster, right? So can you convert my FASTQ files to faster? And then save that into the new directory that I just created here. And then call that new directory using whatever the base name is, because remember you're dealing with different files, right? You're dealing with different more than one file. So it's just gonna use whatever the base, like let's say your file was example1 .fastq. So it's gonna say now, and then your other file was example2 .fastq. So that then means this is gonna save your files using whatever the base was. So the example one is gonna be example1 Q20 filtered converted to fast, which basically means this is a FASTQ file that only contains bases that are like the quality that I used to filter this was more than 80%. I then save that as a faster file, right? So I feel like if you name your files by exactly what you did to them, you're gonna be able to know like 6 months or 7 months down the line where you put the files that you filtered using maybe 80%, you know? I mean the base pairs that you filtered maybe using 80% or whatever that you thought was best. And how do you know what to use here? Well, publications. And then I also included just BSF tools. So of course, just because I can do all of this with CCAT doesn't automatically mean I can be able to do all of that to then a VCF file, because it's no longer a .fastq, right? I'm now dealing with a .vcf. So with that .vcf, there's also other scientists or software engineers or software developers that have spent some time in getting to know how VCFs, the structure of VCFs, right? So they know exactly what to use when you are filtering it, for an example, or what option it should they should give the user, like to give them freedom onto what they want to be filtering their files with, right? So VCF tools is a tool that we use when we are working with VCF tools. We also have a tool called VCF tools, which is also a tool that we use when we're working with VCF. But so basically how we can look at VCF tools is if you're working with your VCF files and you want to transform them, you want to filter them. For an example, with VCF files, we know that they contain variances, right? It's a tool that we use to store variants that have been found to exist in a certain genome, right? I'm not gonna go deep into that because yeah, but then what I'm just trying to teach you here is what to use when, for example, your supervisor is like, hey, so I have this VCF files that I want you to perform 1, 2, 3, and 5 with, right? So you can then download hopefully you're going to be able to set up your environment that's contained the BCF tools, and then you can be able to use it to transform your VCFs. By transform, I mean like filtering it, because of course, like if you're getting a file, it doesn't, like everything that's contained there, it's not things that you can always use. Sometimes we also have low quality base pairs that are still in there, right? Which is why you have to go through this whole process there of transforming your files and using the parser to just make sure that yeah, no, it's not gonna be a break, guys. I think I'm gonna release you. And then another tool that you can use to then transform your files, let's say you're working with, because we also work with CSVs and TSVs, like the same one that you work, CSV. So you can also use pandas for this, but we do have specialized tools that you can use when you're dealing with your metadata. So your metadata is just a file that contains information about the samples that you might be working with. Like, for an example, what I'm working with MTBs. So I have VCF files. So I have like one sample per VCF. So what I'm trying to do with that, I'm trying to take my VCF files and convert them into a format that machine learning, like deep learning, can be able to then read, right? And obviously, because of the fact that my VCF file is not a flat file, it's not something that you can just know now what to extract and what to use to filter it and stuff. That's the reason why I use the VCF tools docs, because they also have documents that go deeper into whatever algorithms that they have described on their analysis. So yeah, so CSV cut is also another tool that you can look into if you're ever working with VCF files and you're trying to manipulate them, or maybe trying to filter them to whatever your research question is. So you can CSV cut is also another tool that you can look to. So yeah, that's about it. But anyways, I don't want you to get discouraged by not being able to set up the Conda environment. Like, that's the reason why even CHPC decided to hire a person specifically to just deal with that, because it's not always straightforward. It's not always straightforward to it's not always like straightforward. So yeah, I think for me, one thing that helps me more than anything, like to maneuver around bioinformatics, because with the kind of work that I do, I'm dealing with a lot of students and they're all working with different things, right? And when a person logs a ticket on the class, I mean, when they log the tickets, they all be expecting that you know exactly what they're talking about. And that's always never a case, because bioinformatics is really broad, hey? And it's growing as I'm sure right now as we are talking, there's someone who just thought of this brilliant idea to write a certain function that we can apply onto our bioinformatics tool. I mean, onto our bioinformatics data. So it's always growing. Like I'm always getting new installation requests. So of course, I'm not gonna know how everything works, right? So that's why I always encourage people to just go through those documents, go through that manual. Hey, I promise you're gonna find like there's not one thing on the manual that there's not one thing that's not explained on the manual. So yeah. Thank you so much for your time. I hope I'm gonna meet some of you in these conferences. So yeah, thank you.
Okay. Sure. Okay. Thank you, Namdi. As some you can see, let's just go to the chats. I think people have been asking quite similar questions and had issues with setting up their environment. Maybe that is something that people can just, students can just go through at the champions, on their side, on themselves. They can just go through Canvas, I think, step by step there, make sure that the corner environment speak with each other, collaboration, I'm sure maybe you'll find few in your class that has already set up the environment on Windows. That can be useful as well. I tried to set up on my side on Windows, quite some few steps worked as well. I haven't done the whole thing as far as my side as well. So yeah, thank you very much, Namli. Is there any quiz that you would like the students to do? Or there's no quiz for this one? Hi, Namli. Okay, it's fine. We'll just go through and just share my screen.
Yeah, sorry, Vuyo. I've been speaking to myself. No,
Okay.
there isn't a quiz for this. I mean, it wouldn't be fair, would it?
Yeah, it's fine. Okay. Okay, no problem, Namdi. So I'll just go through tomorrow's schedule, and I think we might leave a bit early. I doubt if there's no quiz, and people can just go home or maybe stay around just to figure out and set up their environments, go through the script. Okay.
Yeah, if anyone needs any help, I'm available. I'm just gonna be on Slack to help you with setting it up. Because I feel like with setting up the corner environment, it's one of those skills that, especially if you're a bioinformatician, once you master them, it helps you a lot.
Yes. Okay, so one of the things that I noticed on your presentation on the as well is that people were so concerned about the steps as well as the commands that are on the file. Of course, not everyone is going to understand that and all the modules that are within the environment as well, because they are not there, they couldn't install the environment, they couldn't set up the environment. So probably most of the modules won't be on the environment as well, on the Conda environment. So yeah, that might be the issue maybe when checking the script as well. Some of the commands and some of the lines on the scripts require you to have the environment set up, basically.
And also the files, yes.
Yes. So yeah, these are the files. Basically, you can find the files on your on your day 4, I think. So if you can go on your day 4, let's go back. Let's go to day 4. There you go. So yeah, here's day 4. There's computer literacy for biometrics. So you can just go through all those steps there. 4.2, setting up the environment. They normally mentioned all that. Step by step. Click on next. If you click on next, you will see all the files are in there. So then you can just take those files, download them, set up maybe a repo with those files and open using Spider, and you will be able to see some of the files. And you can just go through the files, set up the environment and see. Maybe tomorrow morning we might start with a session where now the issues that you guys were facing, maybe if you went through the steps and you face some issues, make sure you're on the Conda environment again. So yeah. Okay.